Hi, my name is James Irvin Briones and I am from BSCS 3B. For today, I will tackle all about artificial neural network. The term artificial neural network is derived from biological neural networks that develop the structure of a human brain. Similar to the human brain that has neurons interconnected to one another, artificial neural networks also have neurons that are interconnected to one another in various layers of the networks. These neurons are known as nodes. So this is the structure of a biological neuron, which have the dendrite, cell nucleus, axon, and the synapse. And this is the structure of an artificial neuron, which has the input, the neuron, and the output. So, the biological neuron versus the artificial neuron, the comparison is the dendrites from biological neural network is the inputs in the artificial neural network, while the cell nucleus is the nodes, synapse as the weight, and axon is the output. The structure of an artificial neural network. Artificial neural network primarily consists of three layers. The first is the input layer. As the name suggests, it accepts input in several different formats provided by the programmer. Second is the hidden layer. The hidden layer presents in between input and output layers. It performs all the calculations to find hidden features and patterns. And the last one is the output layer. The input goes through a series of transformation using the hidden layer, which finally results in output that is conveyed using this layer. So this is the structure of an artificial neural network. The yellow is the input layer, and the hidden layer is the color sky blue and green. So the last layer is the output. So the input goes here, and then it will go to the hidden layer to filter the information until it gets the output. So, the artificial neural network takes input and computes the weighted sum of the inputs and includes a bias. This computation represented in the form of a transformation function. So, these are the formula how they compute to get the output. It determines weighted total is passed as an input to an activation function to produce the output. Activation functions choose whether a node should fire or not. Only those who are fired make it to the output layer. There are distinctive activation functions available that can be applied upon the sort of tasks we are performing. So this is the example of an artificial neural network that has a computation. So for example, we have the value of the x have a value of 1 and 3. And the w have a given value of 2 and 1. And the bias is 1. So we will distribute it. So this is the x1 is equals to 1. This is the x1. And the x2 is equals to 3. While the weight 1, which is equals to 2, and the weight 2 is equals to 1. So, the computation is, we're going to use a sigmoid so that it is the function of x sub n. I'm gonna use a n as a substitute to the number. X sub n times weight time weight sub n plus x sub n times weight sub n plus the bias. So the value of x1 is 1 times the value of weight 1 is 2, while the value of x2 is 3 times the value of weight is 1 plus the bias. So the function is equals to 6, the function of 6. And then after the computation, it results as 0.9975. So we already compute. So we already compute this and this. So after that computation, we're going to compute the next. We're going to compute this. erase. Eraser. We're going to compute this. So, the output is O plus 1, O sub 1 is the O1. So, the function of, and then the value of, then this formula, we're going to use this formula. And then the value of this, which is H1 and H2, is the 0.99.75. So, 0.99.75 times this, the weighted, which is equals to 2. So, 0.99.75 times 2 plus 0.9975 times 1. So, the result is the function of 3.9925. And the output is 0.0181. So, what happens in this computation? So, for example, I'm inputting, I would like to know I will I would like to know if it is a dog or cat, and I will input some images, and then I will go back to explain it further. Okay, so the example is, if I will input a picture of a dog or cat, it goes here, and then the input goes to the weighted and goes to the nodes, and then the nodes will compute if it is for example, if dog is the codes are if the dog is greater than or equals to 0.0181, it is a dog, or else it is a cat. So it will compute, and then it goes here, it will flow out, and the output will come out. Erase all. So the next is the types of neural network. Feed forward. The first types is the feed forward neural network. One of the simplest variants of neural networks, they pass information in one direction through various input nodes until it make it to the output node. The network may or may not have been hidden node layers, making their functioning more interpretable. It is prepared to process large amount of noise. This type of ANN, or artificial neural networks computational model, is used in technologies such as facial recognition and computer visions. The second type is the recurrent neural networks. More complex. They save the output of the processing nodes and feed the result back into the model. This is how the model is said to learn to predict the outcome of a layer. Each node in the RNN model acts as a memory cell, continuing the computation and implementation of operations. The neural networks starts with the same front propagation as a feed-forward network, but then goes on to remember all the process information in order to reuse in the future. The network's prediction is incorrect. Then the system self-learns and continues working towards the correct prediction during backpropagation. This type of ANN is frequently used in text-to-speech conversations. And the next is convolutional neural network. one of the most popular models used today. This neural network computational model uses a variation of multi-layer perceptrons and contains one or more convolutional layers that can be either entirely connected or pulled. These convolutional layers create features maps that record a region of image which is ultimately broken into rectangles and sent out for nonlinear. The CNN model is particularly popular in the real realm of image recognition. It has been used in many of the most advanced applications of AI, including facial recognition, text digitization, and natural language processing. Other uses include paraphrase detection, signal processing, and image classification. The convolutional neural network utilize a reverse CNN model process. They aim to find lost features or signal that may have originally been considered unimportant to the CNN system's task. This network model can be used in image synthesis and analysis. And the last one is modular neural networks. Contain multiple neural networks working separately from one another. The networks do not communicate or interfere with each other's activities during the computation process. Consequently, complex or big computational process can be performed more efficiently. Now, we're going to tackle all about the advantages of the artificial neural network. The first is parallel processing capability. Artificial neural networks have a numerical value that can perform more than one task simultaneously. The second is storing data on the entire network. Data that is used in traditional programming is stored on the whole network, not on a database. The disappearance of a couple of pieces of data in one place doesn't prevent the network from working. The third is capability to work with incomplete knowledge. The ANN training, the information may produce output even with inadequate data. The loss of performance here relies upon the significance of missing data. And the last one is, or fourth one, having a memory distribution. For ANN is to be able to adapt. It is important to determine the examples and to encourage the network according to the desired output by demonstrating these examples to the network. The succession of the network is directly proportional to the chosen instances, and if the event can't appear to the network in all its aspects, it can produce false output. So this is the last one. The last one, having fault tolerance. Extortion of one or more cells of ANN does not prohibit it from generating output. And this feature makes the network fault tolerance. Now, we'll tackle the disadvantages of artificial neural network. Assurance of proper network structure. There is no particular guideline for determining the structure of artificial neural networks. The appropriate network structure is accomplished through experience, trial, and error. The second is unrecognized behavior of the network. It is the most significant issue of ANN. When ANN produces a testing solution, it does not provide insight concerning why and how it decreases trust in the network. The third one is hardware dependence. Artificial neural network need processors with parallel processing power as per their structure. Therefore, the realization of the equipment is dependent. And the fourth one is difficult of showing the issue to the network. ANNs can work with numerical data. Problems must be converted into numerical values before being introduced to ANN. The presentation mechanism to be resolved here will directly impact the performance of the network. It relies on the user's abilities. The duration, and the last one is the duration of the network is unknown. the network is reduced to a specific value of the error, and this value does not give us optimum results. And now we'll tackle about the applications of artificial neural network. Image recognition was one of the first areas to which neural networks were successfully applied, but the technology uses have expanded to many more areas, including the chatbots, natural language processing, translation, and language generation, stock, stock market prediction, delivery driver route planning and optimization, drug discovery and development. So that's all about the artificial neural networks. So thank you for listening, and I hope you learned something from me. Thank you.